Hello everyone, my name is Walter Schaefer. I am from the company AI Quantum. Together with the Institute for Technical Chemistry at KT, we have developed a measurement method for monitoring slurry sprays. Slurry sprays are complex two-phase flows with many critical fluid mechanical and aerodynamic parameters. Our method focuses on monitoring the stability of the concentration and the size of suspended particle in the sprayed suspension. A slurry spray generally consists of dynamic suspension droplets, which are composed of a base fluid and solid particles. Our measurement method can analyze these suspension droplets to determine the concentration and estimate the size of suspended particles. Our approach is based on the light scattering analysis of the suspension droplets that pass through an elliptical Gaussian laser beam. When an individual suspension droplet moves through the Gaussian light beam, light scattering occurs, and the scattering intensity is registered by several detectors placed at specific angles. In our technique, we detect the light interaction with the surface of the suspension droplet and with the content inside of it. By analyzing the light scattering signals, we can extract characteristics for each individual droplet, such as transparency, size, and velocity. Since we measure individual droplets, we also record the acquisition time of each droplet. To estimate the concentration and size of solid particles inside a droplet, we analyze statistically the ratio of droplets with different transparency properties. To validate the method, we conduct experiments using a gas-assisted coaxial nozzle. We tested suspensions with different concentration and solid particle sizes. On one side you see microscope images of the different suspensions, and on the other side there is a part of the experimental setup. In the first measurement, we adjust only the suspension concentration in the slurry spray, while keeping the size of suspended particle constant. As expected, the slurry spray with a suspension concentration of 20% has significantly more non-transparent droplets than the slurry spray with a 5% concentration, as can be seen in the droplet size distributions. In the second set of measurements, we observe a similar trend when we adjust the size of suspended particles in the slurry sprays while keeping the suspension concentration constant. This measured correlation can be explained by a modified Lambert-Beer relation, which describes the interaction between the light beam and the suspension droplets. First, two obvious facts. The absorption of the laser beam by suspension droplets is proportional to its size and the suspension concentration. Second, a less obvious fact. At the same concentration, smaller suspended particles have a larger total surface area, leading to more absorption. Let us summarize the experimental result in a graph. The graph on the one side shows the correlation between suspension concentration and the ratio of transparent to non-transparent droplets. The graph on the other side shows the correlation with the size of the suspended particles. From the experimental results, we see that there is a range where the proposed method can be used for slurry spray monitoring in terms of suspension concentration and particle sizes. Looking ahead in expanding the application range of our method, we plan to analyze the light scattering signals more deeply using a machine learning approach. Thank you for your attention. Bye bye.